Good morning, everyone. Today, inshallah, are you sure? Fatin, okay. Today, inshallah, we will start our new semester for Calculus 2, previously called Mathematical Analysis 2 for FCT students. Very, very happy to be with you today, and I miss you all really in the last day. Today's lecture, it contains a lot of information. As I told you before we start recording, all I want you to do is just watch it and then try as much as possible to remember the equations that I'm going to say to you. Most of them, you saw them previously, but we will try to make them as easier as possible for you, as easier to remember even, okay? And I will start with some information about the assessment of the exams and everything for this semester. So the assessment system will be as follows. We will have 2 midterms. Hopefully, they are not going to be MCQ questions, but if there is, it's going to be easier than the ones that we saw previously in the previous course. It's going to be very simple. He will give you 4 alternatives and you will choose the right answer out of the 4 questions, away from the psychological effect of the choose the right answer from the following. Okay, so it's a lot better and inshallah easier. Okay, as I told you, we have an average of 2 midterms. The average is 50% in each one of them. So you will have 2 midterms. Do the best that you can to get greater than 9.5, okay, and you will be approved for this semester through the two exams. A student will be considered pass, as I told you, if you get more than 9.5. Exam times will be announced in the coming slide. Okay, if a student got 18, I'm sorry, Jean, you will have to have another exam to defend this grade. If you didn't participate in this exam, you will be capped at 17. So if Ziad got 19, he will have to in the both 2 terms, and I'm sure he can do it easily. Okay, then he will have to have another exam to defend this grade. If he didn't show up, or he didn't attend, or he didn't want to, we will cap the 19 to be 17, okay? Very good. If a student didn't pass, he will have to enter a global final exam, covering the contents of the first and second midterm both together. The course is absolutely outstanding. It starts from the first knowledge about curves, about famous quadratics or famous surfaces and stuff like that, taking you into the definition of topology of an interior point, accumulation point, the sets and so on. Then we will go to various types of functions, functions in one variable, functions in several variables, and functions in vector variable functions, which serve, we will go to that at that time. And then we will go after functions to limits, to continuity, which is an introduction to derivative. And also we will take the difference in differentiation between a single valued function or a function in several variables or a vector valued function, all types of functions. So you will be a professional in this mission, which is finding a derivative for any type of functions. Then we will stop and we will go through various types of integration. Either just only integration, integration 2-dimension, integration in 3-dimension, or multiple integrals. The various types of integration, either it is a contour integration or regional integration or integration through a volume, we will cover all of this. And that's the end of our course. Are you with me? Good. This is why it is really very important to get the knowledge of this lecture, as I told you. About the exams, the assessment equations, 50% first midterm and 50% for the second midterm. I know, Fatin, you asked me about this. The first midterm is going to be on the 8th of April. Okay, it will be paper-based, and it will be on Wednesday. That's the 8th of April. The second, yes, 8th of April. It's going to be Wednesday. And the second midterm, it will be within the 2nd of June Okay, it will be 11 a.m. Cairo time, and it will be residential and running for 2 hours. أي مشاكل؟ مبسوطين؟ شوف مبسوطين ازاي؟ مبسوطين؟ طبعا الحمد لله. The final exam, as I told you, date will be still unknown, but it will be down the road, inshallah. By the idea, all the exams we have tried to make the exams exactly like the ones running in Lisbon at the same day and the same time, almost same time. So you should be in a very good shape. Okay? طيب يلا بقى نبدأ. أول حاجة, the first thing that we will talk about, Mr. Ziad, Ms. Fatih, خلاص. خلاص Mr. Ziad? Okay, we will talk about analytic geometry. The analytic geometry, it's a start of having the curves and their equations as I introduced earlier. Okay, the analytic geometry, also called a coordinate geometry. They have the same name, the coordinates geometry, and it reflects how we depend on the type of the right coordinates in order to take our shape or function or whatever. It's the study of geometry using coordinate systems and the principles of algebra and analysis. Of course, this is just for you. Why we study analytic geometry? Analytic geometry is widely used in physics and engineering, in the foundation of most modern fields of geometry. Anything that you want to evaluate in precise, exactly, you will have to have its equation and so on. Also, it is concerned with defining and representing geometric shapes in numerical way, concerned with extracting numerical information from shapes, numerical definitions, and so on. Here's some photos just to encourage you about the analytic geometry. I can evaluate the components or the precise components of circles, spheres, discs, whatever in high accuracy. If you run it in the gear, the head of a gear or something like those parts, you will be able to do this analytically using what I'm telling you. بص شوف الحركة دي جديدة جدا. Okay, curved road design in civil engineering. I'm using all the knowledge of this parabola and that parabola and the circles and the ellipses and so on in order to generate something like this, because we don't write a road or just to move. It has to be designed for the cars in order to be able to move around, okay? And also, as you can see, I like this photo also, which is an application of the ellipse, as you will see from down the road. Also the stone arch from Minnesota in Minneapolis, a direct application on the evaluation of various loads in the design of a geometric shape, which is a which is going to be an elliptic paraboloid you will see down the road, apart from that. Also the arched curves, like this one, the arch girder, which carry this bridge with all the loads that's moving. You need an accurate calculation and an accurate dimension for doing something like this. Also for the antennas, if you are in communication or anything, you will need to know a lot about paraboloids and their coordinates and their equations in order to be able to evaluate the focus of where we put our antenna in order to be sure that we have most of our waves gathered together, and that's the main purpose of something like this. Preliminaries of analytic geometry, it will start from the understanding of the Cartesian coordinates, starting from the x and y, the x-axis and y-axis. Any point in the plan I can reach it very easily by the coordinate system that I'm using. So if I'm using the Cartesian, all I have to do is to move just for A and X direction and up in the Y direction in order to determine a point. And you have here multiple examples of points representing how to reach each one of them just by moving in a distance in X and another distance in Y. Okay, this is really very important. Also, the definition of a distance in analytic geometry and the equation regarding this distance, it's really very important, which, yes, Ms. Jana, it is the norm of a vector also. The distance, it's simply fathom the difference between the coordinates. So if I have 2 points and for any reason I want to evaluate the distance connecting these 2 points, all I have to do is to get the difference in x, the difference in y, both of them squared under square root. I have the distance. And yes, Ziyad, it is also the norm of a vector, if you remember from linear algebra. If I have a vector, and if I want to get the norm of the vector, or the magnitude of the vector, all I have to do is to get the sum of the squares of each component under square root, okay? So that's the law of the distance. As I told you, these are 2 points. Okay, don't worry about which one of them will be point number 1 or point number 2, as long as you are doing the same exact difference in evaluating distance. I know, Fatin, you saw this plenty of times previously, but just I'm gathering them for you at the time being. Okay, for example, and that's a trivial one, if I want to evaluate the distance between these 2 points, all I have to do is to get 3 plus 5, because it's a minus negative of 5 to the power of 2, plus 4 minus 2 to the power of 2 under square root. Then I will get the distance as you can see. زياد بص شايف الحركة دي شديدة. Miss Fatin, if you look to problem number B, you will discover 2 things. Yes, you are right. You don't have to use this distance law, because once you look to these 2 points in B, which is 1, 5, and 6 and 5, they are points on a horizontal level. صح جانا؟ On a horizontal. ليه horizontal؟ لأن ال y coordinate constant. So actually the distance between them is 6 minus 1, which is 5 units, okay? Also, I can do it exactly by using the distance law, and it will give you the same. For the second point or pair of points, which are negative 1 and 2 and negative 1 and 6, you will remark that we are moving vertically. I'm at negative 1 and negative 1, and I'm moving to negative 1 and 6. So if I want to evaluate the distance, it's very, very simple. All I have to do is to get 2 minus negative 6, or negative 6 minus 2, which is going to be negative 8, that's an 8 units. Also, you can apply the law of the difference in order to evaluate the distance, and you will be able to have it. It's exactly the same. All of this are trivial knowledge by the idea. Just to remember, once if you want to get the distance between 2 points, you can use this law as I told you.
وفي calculator في الامتحان؟
What?
calculator في الامتحان؟
ما عندناش دلوقتي regulation على اليوز اوف calculator, but I don't think هنشوف وقتها يعني مش مشكلة. طيب ايه هو الجريدينت؟ الجريدينت يعني السلوب. طب السلوب اللي هو عبارة عن ايه؟ السلوب هو الفيرتيكال رايز على الهوريزونتال ران، او الديفرنس ان واي على الديفرنس ان اكس. على فكرة السلوب ده مهم جدا، لأن السلوب أو الريت اوف تشينج it is the entrance for derivative. Derivative is defined as the continuous rate of change of a certain value. So it's very, very important. Okay? So a gradient, it's really very simple. All I have to do is to get the difference in y divided by the difference in x, as you can see. One of the famous slopes that you will never forget, the slope of a vertical line. The slope of a vertical line is undefined. What's the slope of a horizontal line? The slope of a horizontal line is 0. So I have now just reviewing your background and just stressing on these facts. So for the slope of a horizontal line, it's equal to 0, as you can see. If I have 2 lines and they are parallel, so their direction ratios are equal. Do you remember from linear algebra? And also here in 2-dim, their slopes are equal. If I have 2 lines and they are perpendicular, then the slopes are, if you multiply them together, the result will be negative 1. Or one of them is equal to the reciprocal, negative the reciprocal of the other one. So simply, for M1, 2 lines with 2 slopes, M1 will equal to negative 1 over M2. That's the condition for perpendicular 2 lines. This is y equal mx plus b. This is the slope. خلي بالك يا فاتن لازم يبقى y positive in one side, y positive in one side with no coefficients, and then you will have your slope in front of x. This is an important remark. Okay. Also, we can get this is just a definition because we are going into conic sections. So we can look to conical sections or the cone in general as a movement of a straight line around a circle. Okay? If you take just a straight line and you make this line to move around a circle, his movement will draw a cone like this one. Okay? طيب, perpendicular distance from a point to a line. This is really a very helpful equation. All you have to do is to get the equation of a straight line equal to 0. So you will have to move your equation to equal to 0 for the equation of a straight line. Then all I have to do is just to substitute in this term. So if the equation of the straight line was y equal mx plus b, make it y minus m of x minus c equal to z. Take this equation and put it on the denominator. Then divide by the square of the coefficients in front of x and y squared. And then replace each x and each y by the coordinates of your points. Then you will have your perpendicular distance from a point to your straight line. تاني, once more, ازيك فريد؟ أخبارك؟ Once more, okay, once more. If I want to get the perpendicular distance من بقه, if I want to get the perpendicular distance from a straight line, between a straight line and the point, all I have to do, boss, all I have to do is to get the equation of a straight line on the denominator, divided by the square, the value in front of x to the power of 2 plus the value in front of y to the power of 2, replace x and y by the coordinates of the point. It's gonna be okay? So that's the distance between 2 points and the straight line. Okay, بص على البروبلم. I want to get the the perpendicular distance between the point -3 and 7 to the straight line y equal to 1.2x plus 2. For any reason, I want to have this perpendicular distance. It's really very simple. زياد بالله هات لي مناديل من الاستوديو بس عشان اللي انا هعمله ده صح وانا هستنى لغايه ما انت تيجي. For Farid and Nada, I've told your companions that this lecture is very important because it's gathering plenty of information. I'm in the beginning. What's a straight line? Determining a point, a distance between 2 points, equation of a straight line, the relation between two straight lines, two dim, when they are parallel, when they are perpendicular, and so on. Farid also tried to change, the group, our WhatsApp group, linear algebra, to be mathematical analysis to, calculus 2 FCT, let it calculus 2 FCT, in order to send you the PDF for this lecture, okay? And we will start from there. Okay, I will start step by step till Ziad comes. بصوا, the first step that I will do, okay? The first step that I will do is the following. Step number 1. I will put this equation, y equal negative 1.2 of x, negative 1.2x, negative 2 equal to 0. I will put the equation in this way. Okay. ماشي؟ بصوا, يبقى all I had to do is just to shift those numbers to the other side. This is step number 1. The second step, I will get the perpendicular distance, which is gonna be on this form. Write the equation on the denominator, minus 1.2 minus 2 divided by the square root. The number in front of y to the power of 2 plus the number in front of x minus 1.2 معانا to the power of 2. So that's a preparation for the equation of a straight line. Then I will do the following. Boss, I will replace y, okay? I will replace the y by 7. And will replace x by negative 3. So that's all I have to do, is to replace by this guy by 7 or that guy by negative 3. The distance will be in front of you. Okay يا شباب؟ تمام، حلوة. work beautifully. Very good. اوكي خلاص يا شباب؟ ها تمام؟ زياد معايا؟ فهمت انا عملت ايه؟ اوكي. تاني once more, that's the equation of a straight line. I already will expand it on this manner. Then I will put it on the denominator, as you will see. Then replace x and y by the values which are -3 and 7. Jana, in this case, I've tried to adjust 6/5 by multiplying the equation on 5. Just to avoid the fractions, but in the previous substitution, I didn't do that. All I have to do, the only regulation, is to have your equation on one side. If you have your equation in one side, then you will be in a very good shape. ماشي؟ اتفضل.
هي دي اللي تحت دي هي equation of the distance between two lines?
Between ايه؟
Two lines?
Yes, almost like it, because the distance between two parallel lines, I can get it from having a point in one of them and get the perpendicular distance, so it's almost the same. Okay? That's the equation. بصوا انا خدت اللي قدام الواي in front of y square in front of x square ولبست الواي بالاكس by the coordinates. Okay, very good. Any questions for this part? I don't think there is any questions. Okay, now moving to the conic sections, which is also very important. In this part, I will just show you plenty of relations in each one of them. Careful for the pen in front of your eyes. Okay, the intersection of the right circular conic. أولا ليه سميناهم conical أو conic sections? Because all of them can be found by making an intersection of a plane with a cone. So you will have their names. This is why their names are like the conical system, the conical sections, which are the ellipse, parabola, and hyperbola. This is the ellipse, as you can see. If you have your plan cutting either parallel to the base or just with a slight inclinedness, you will be able to get an ellipse. If it is just parallel to one of the sides, you will get a parabola. If it is vertical, you will get a hyperbola. بص كده لو انا بخرطه ده الكون بتاعي اهو، تخيل الكون اهو وانا بخرطه. اوكي، هتطلع الشكل بتاع الكروس سكشن as an ellipse. either لو انا بعمل البلان بارل، يعني لو ده الكون بتاعي وانا بقطعه كده هيظهر عندي الاليبس بتاعي او سيركل. طيب لو انا خليت البلان معوج سنه برضه هيديني شكلان اليبس. لو انا يا فريد طلعت لفوق بدرون وبصيت على الشكل هيظهر الشكل بتاعك كده لو انا طلعت لفوق. يعني لو انا طلعت بصيت عليه من فوق ده وانا بقطع من تحت، ده وانا بقطع هنا، لو انا طلعت من فوق وبصيت من فوق ده الشكل اهو، شكل الكروس سكشن ان اليبس as you can see. برضو ده شكل الكون لو انا قطعت ببلان مايل هيروح مديني خرطه هنا، فاهم؟ الجزء اللي انا قطعته ده هيبقى شكله عامل ازاي؟ بارابولا، صح كده؟ صح، شكله بارابولا. طيب لو انا مسكت الكون ده ورحت جاي قطعه ببلان، ماشي؟ وليكن باراليل للمين اكس، حاجه زي كده، هيروح مديك بارابولا فوق وبارابولا فين؟ تحت، which is a hyperbola. اوكي، ده الثري شيبس وليه اطلق عليهم كونيكال سكشنز. اوكي، الحته دي حلوه قوي، الباراجراف ده انا عايز اقول لك. دايما بضرب المثل ده للماي ستودنتس يعني. زمان مش وانا صغير كان نفسي، لا يعني انا كنت عارف مرفه جدا يعني، ماشي، فكان ساعات اما انزل الشارع كان بالنسبه لي يعني اكسبيرينس خطيره قوي يعني، واخد بالك؟ فاول ما بروح البلد عندنا العيال كانوا عيال مزاج جدا يعني، كان عارف الفراشه اللي هي الدراجون فلاي، الدراجون فلاي يعني انت تبقى غلبانه كده ونضارات عامله زي طياره الكبتر، انا دايما بشوفها بفتكر طياره الكبتر،
لا ده بتخاف منه،
واخد بالك؟ وايديهم ايه بيتحركوا كده بمحبه. فالناس كانت تعمل ايه؟ تاخد الديل ده تربطه بفتله، يعني ولاد صغيرين يربطوه بفتله، خلي بالك عمليه مسليه جدا. تمسك الفتله دي، هي ايه اللي بيحصل؟ هو مش بيربطها يقطعها، هو بس بيربطها، هي طبعا بتموت بس ما كيرز يعني، بيربطها بفتله ويمشي. ايه اللي بيحصل؟ هي بتحاول انها تتحرك حركه راندوم، صح؟
فبتبقى سيركل،
ودايما هي بتبقى شاده الحبل ده لفين؟ للاخر. فهي مش هتلف بقى كده زي مكنه، لا هي هتمشي اليماني بعدين تيجي اليماني بعدين تيجي اليماني، بس انت ماسكها بايه؟ بفتله. طب انا ضربت لك الفكره بتاعت الغزاله الدراجون فلاي دي ليه؟ لان اكشوال الموفمنت بتاعت الكرييشن بوينت في نقطه بتتحرك ونقطه ثابته. There is a constant point يا فريد و there is a moving point. If I'm talking about the 2 dimension, the constant point it's like 0 and 0. It's like 2 and 1. You will go 2 units in x, 1 unit in y, it's fixed. It's not moving. But the point x and y, it's a moving point. Because it takes all the values of the x-axis and all the values of the y-axis. So the point of view of analytic geometry looks to this moving point. This moving point, which is the point responsible about doing anything in the plan or even in another dimension, this moving point under certain condition, you will make it drawing certain something or certain shape. So for example, if you have a constant distance for this moving point and the fixed point, and you are moving under the condition that this distance is fixed, you will be able to draw a circle. Like the ones that I told you about, if you have this string and you have this dragonfly trying to fly away as much as possible, but your string is preventing her from doing this, she will move on the surface of a sphere around you. You understand what I'm saying? معايا يا شباب؟ Okay, that's the main concept of having in geometry. So a classical definition in analytic geometry is about a conic that it can be defined at the locus of a point moving, which is the point that we are talking about, x and y. Under certain condition, it will give you what you want. In some cases, the length from a fixed point is constant, and that's gonna be the locus of a circle, for example. Okay, if you change the condition, you will be able to have another equation and so on. This is why, if you want to get the equation of a straight line, all you have to do is to get x minus the coordinates and y minus the coordinates. This is the equation of a straight line, if you remember. And a general equation of a straight line with 2 points, do you remember it? حد فيك فاكر equation of straight line between 2 points? كنت بتعمل ايه مستر فريد؟ كنت بتجيب y minus y1 divided by x minus x1 equal to y2 minus y1 divided by x2 minus x1. What you are saying here, if I have the moving point, which is y over x, and they got a variable or a gradient between this point and the fixed one, and put it equal to another fixed gradient, then you will have an equation of a straight line. A moving point, but just moving on a straight line. Okay? This is the main concept, as I told you, of the analytic geometry. We will go through this plenty of times when we are going through the various shapes. Okay, this is the general equation of all conics. بص يا فاتن, the general equation of all conics يعني circle, يعني ellipse, يعني parabola, يعني hyperbola, يعني 2 lines multiplied each other. This equation can represent a circle, an ellipse, a parabola, a hyperbola, or 2 lines multiplied each other. This equation. Okay, so under certain relation between A, B, C, or between the coefficients A and B and C, you will be able to get your shape or the relation connecting them. So Nada, for example, if you got B squared minus 4AC, which is called, describe this relation, the gamma or the discrement. If the discrement is equal to 0, then you will have a parabola. If your discrement is less than 0, you will have an ellipse. If your discrement is greater than 0, you will have a hyperbola. If both A and C are equal to zeros, you will have a circle. That's a way in order to classify the shapes that are coming from a quadratic equation, okay, in 2 dimensions. I will talk in specific at the time being on the perfect equation of an ellipse. The best equation of an ellipse, it is the equation Okay, what's an ellipse? First, it's the ellipse as described in this paragraph. It is the movement of a point x or y where its fixed distance between two fixed points is constant. This is why I can draw an ellipse simply if you have bind a string between 2 points, and then you are moving a pen through these 2 lines but keeping the distance constant between both of them, you will be able to graph an ellipse. يعني خلي بالك المسافة ده هي ثابتة وده القلم بتاعي وانا هحاول اتحرك بس بحيث ان التو لاينز مشدودين. النتيجة you will be able to draw an ellipse as you can see. ماشي؟ So it is the movement points that I'm telling you about, which is x and y, and this is how we can draw it. بص ندى and فاتن please خليكم معانا. Also we can define the eccentricity, which is the difference between 2 dimensions, which is a ratio actually, but it will be related to the ellipse or parabola or hyperbola. It will be also another tool to classify them, which is an electricity. I'm sorry, the eccentricity. I will go through it right now. This is the equation of an ellipse, as you can see. I'm sorry, the shape of an ellipse, as you can see. The shape, the ellipse in general, it have a center. It had 2 vertices on the x-axis, 2 vertices on the y-axis. And it has 2 foci or 2 focuses on the x-axis. If I measured the distance from any moving point on the shape of an ellipse, BF, and then divided on the perpendicular distance between this point and the directrix, so I'm getting BF over BD. If I get this distance or this ratio will be less than 1 for all ellipses. But for a specific ellipse, it will be constant. So for a certain ellipse, let's say it's going to equal 2.5. At any point on the surface of this ellipse, the eccentricity will be 0.5. But in general, any ellipse, any other type of ellipse, okay, its eccentricity is equal to less than 1. Once more, what is the eccentricity? The eccentricity, it is the difference between the point and the focus and the point with the line, the helping line, which is the directrix. Okay, that's the equation of an ellipse as I told you. The circle, it has no eccentricity. The eccentricity must equal to 0. Because simply in circles you have one center. So there is no eccentricity. But in ellipse and the parabola and the hyperbola, in ellipse and the hyperbola, you will have 2 centers actually, or 2 foci, which is a movement from the center to another point. Okay. But in parabola, you will have also a focus, because simply parabolas don't have center, okay? So that's the eccentricity as I'm telling you. Those are the relations that's connecting the general equation of an ellipse. Just a second, أنا بس عايز أكتب لك الإيكويشن بتاع الإليبس. خليك معايا كده. شباب ممكن تركزوا معايا شوية؟ طيب بص كده. X to the power of 2 plus y to the power of 2 divided by a square divided يا فاتن ما ينفعش كده divided by b square equal 1. بص على الايكويشن دي. الايكويشن دي it's an equation of an ellipse. لو ملاحظ هتلاحظ ان عندك x square over a square plus y square over b square equal 1. This is the best shape for an equation of an ellipse. Actually, the 2 radii or the 2 radiuses, A is called the semi-major x, and the B is called the semi-minor x. ده نص القطر الأكبر، ده نص القطر الأصغر. لأن الإليبس لو أنت متخيل شكل الإليبس، ده شكل الإليبس. لو لاحظت ده السنتر بتاعه. ده A وده B. له كام radius؟ له 2 radii. Radius in the X و radius in the Y, and both of them are different than each other. The relations connecting those radiuses together is the relation like B is equal to the square root of A square 1 minus E square. The eccentricity is less than 1. The focus is F. The directrix is L. C, which is A times E, it is the square root of A square minus B square. These relations, أيوة يا فريد كلامك صح. These relations you are not going to be required from you to memorize. Okay? But I want you to keep in mind that the equation of the ellipse is x squared over a squared plus y squared over b squared equal to 1, which is really very simple. And if the equation on this form يا فاتن, the center is 0, 0. The center is 0 and 0. يا ندى, what if the center is alpha and beta? The center is not 0 and 0. The center is different. What's the difference?
Multiplied by
Yes, you are right. It's gonna be x minus alpha to the power of 2 over a squared plus y minus beta to the power of 2 over b squared equal 1. That means that the center is alpha and beta. Yes, Farid, alpha and beta are positive values, although they appear in your equation with negative sign. I have a question. Nada, what if A is equal to B? What's gonna be? Circle. Yes, exactly right. Okay? So it's really very simple as I told you. المعلومات دي واضحة؟ خلاص؟ جدا حلو قوي، مبسوط قوي جدا.
احنا عملناها في فاونديشن.
روعة.
احنا اتبهدلنا بيها في فاونديشن.
طب حلو قوي قوي قوي، حلو. كده جميل جدا. يعني إذا أنت عارف إن ده شكل الإليبس، عارف الديستانسز A وبعدين A over E، وعارف الديستانسز بتاعت البي. طب لو أنا عندي إيكويشن زي دي 64x سكوير 100y سكوير نيجاتيف 64 100 equal to 0. Can you identify the A, B, and the eccentricity? Yes, it's very, very simple. Okay, very good. I will put it just on the case, on the shape, x squared, a squared plus y squared equal b squared equal 1. So all I have to do is to move 6400 to the other side, then divide on it. This is gonna be the shape of the equation. So the semi-major axis كام؟ ندى؟ لا والله ده اللي انت بهدلت فيه في الفاونديشن.
هو اللي قال
10.
بتاع
اوكي الاي ب 10. طب والبي؟
يا جدع ب8.
ب8 حلو قوي. طب والاي اجيبه منين؟ الاي اجيبه منين؟
سكوير روت ده بلس ده.
اوكي minus the difference between them. It's okay. Perfect.